When working with item infos that represent actors in the game world, I want to stress that it's very important to know that the item infos are not the actors themselves. This is a concept I've covered in a few of the past videos, and again, it's very important to know that the actor that is in your inventory should not be the same as the actor that's in the world. Now, we can see this with the cube and the memory target items here. I have two item infos in my inventory. One is of the cube and one is of what we call the memory target. And if I select this cube item info, it spawns a cube in the world. But this cube that is spawned is not the same type of actor as our cube item info. If you take a look at my content browser under the items folder in our demo displays folder, we have our item info cube, and all this item info does is it calls spawn actor when invoked, and spawn actor makes sure that we're on the server, and if we're on the client we simply don't spawn. It gets a location 30 units in front of us and it spawns a cube, and then it simply returns this cube. Now, I've already covered what invoking and how to handle item selection in a previous video, so I won't be covering that again. But I do want to reiterate the fact that the item info base class has many functions provided for you to handle this sort of thing. For example, it has a base invoke function, it has a spawn actor function, and it has a few update from actors, which we'll cover in this video shortly. Now, again, these functions are optional, but if you do use them, it's a good way to kind of kickstart your mechanic framework for your items. However, if you want to create very different behavior for when an item is selected, you can completely ignore the invoke, spawn actor, and update from actor framework. You can roll your own functions and handle things how you would like. Now, again, the cube as in your inventory is not the same actor in the world. And this is done so that we're not storing potentially hundreds of items in your inventory that are ticking and that are calling things that might change their state and might have to keep track of whether or not they're deployed in the world or in your inventory. This is a nice decoupling of what it means for something to be in your inventory versus what it means for something to be in the world. Now, the cube that is spawned here doesn't really have any form of state. You spawn the cube and it's consumed from your inventory and that's it. There's really no purpose for it. It doesn't really do anything exciting. Now, this memory cube example, on the other hand, does have a concept of state. Alright, so if I were to spawn one of these into the world, we'll see that it keeps track of how many times it's been hit. So if we shoot this a few times, we now see that it's got a hit state of 3. It's got 3 hits. If we walk into this target, you'll see that it'll be picked up by the player and is now back in our inventory. And if I were to reselect this, which would then respawn the actor, we'll see that its state is restored back to 3 hits. Now, this kind of gives us the illusion that when we pick this thing up, we're actually picking up and storing everything about this, but we're really not. Right now our inventory does not have a target, and this actor exists in the world, but once I pick it up, we'll see that we have an inventory item, but this inventory item that is stored in the slot inventory component is not that world actor at all. In fact, the actor in the world gets destroyed. All we're doing is we're saving the state information. Otherwise, we would have to have this thing rotate while hidden or something stupid like that, which would eat up a lot of performance for no reason. And this state also works over the network. So if you have another player in this game, they can shoot this thing too, and they can pick it up and drop it. They can pick it up, drop it, you pick it up, you drop it, you shoot it, and everything will stay synced. Because all we're doing is we're storing the state of it rather than the actor itself. Now this does mean that in order to have state information in your actors that are spawned, you do have to do some additional work. Now, first I'll cover the actor itself. We can go ahead and drag one of these targets into the world, and it's already it's built in a way where it doesn't need to be spawned from an item to function. It can just exist in the world, and then we can go ahead and pick it up, like so. So how is this accomplished? Well, when this cube is hit with something, either a pawn or not a pawn, one of two things happen. Either it was hit by a not pawn, such as our projectile from our weapon, and we simply increment our hit value. Now, if it was touched by a pawn, what we do is we see if it has a slot inventory component within that pawn. Notice how we don't have to cast to anything here that is specific outside the core engine framework. This isn't casting to a particular pawn, it's casting to any pawn. And it's simply seeing if we have a slot inventory component there. This means that if you have two completely different player blueprint classes that do not inherit logic from each other, but both inherit from pawn, this will work for both of them without you needing to create custom logic to handle every type of player that collides with us. As long as we have a slot inventory component, this will function pretty nicely. Now, instead of keeping track of an item info along with this actor and updating the reference as the state updates, what we simply do here is we create a new item info object here. We create one using the add item from item info class, which not only creates an item info, but it adds it to our inventory for us as well. So when you call this, all you need to do is simply supply class, which is our memory target item info class. And there's also this other parameter called rebuild bar. Now, rebuild bar causes the UI to re-update. If you're adding multiple things at the same time, it's better to uncheck rebuild bar until the last item is added. That way you're not rebuilding the UI for every item you added, which doesn't really have a purpose, because updating the UI several times in one frame sort of is a performance waste. Moving on, once we have our new item info object and whether or not it was added, what we want to do is we want to have this inventory item be able to capture the state of the actor it represents. Now, you'll see this output is an item info base object, but we're not doing a cast to the memory target item info itself. This because every item info has a function called update from actor. Now, its default implementation simply warns you that if you call this function, it's not implemented, and you should probably do something about that. However, if you have an actor and an item info that represents that actor, you should be overriding the update from actor function in that item info and then handling when you want to update the item info from a particular actor. Rephrasing this, what I mean by this is you call update from actor when you have an actor in the real world that you want to have its state preserved in an item info object. For example, when we pick up this target that has a value of 3 hits here, we want this hit information to be preserved in our inventory. So when we pick it up, when we spawn this item info class, we want to tell this inventory item that we've been hit 3 times. And the easiest way to do that is in your memory target item info and not in the memory target actor blueprint. We call update from actor, and we override it. We cast it to the actor that we assume we're updating from, and here we'll see that we're casting it to our memory target. And again, we're casting this actor to the memory target actor, not the item info, because we are in the item info. We are grabbing its hits value and assigning it to the hits value inside the item info. We're simply copying this property, copying its value, its hit state, to the inventory item itself. And this allows the inventory item to know how many hits this target has been hit by. Now, one thing you'll see here is that we're setting initial spawn to false. Now, initial spawn is sort of a weird property. It's built into the item infos to handle a lot of internal state management stuff. So you don't really need to know how it functions or why it functions, but you do need to know that anytime you spawn or update, or when you are inside those functions and override those functions, when you spawn or update inside an item info class, you should be setting initial spawn to false. This tells the item info that, hey, this item info has been populated, or at least has considered information from an actor in the world, as opposed to being created without any actor representation. Again, you just really need to know to set this to false if you're overriding spawn actor or update from actor, but other than that, you don't need to worry about it. And this should have been checked. So, all right. So when we call update from actor, again, all this is preserving its state from the actor that it is passed. So when this memory target actor is collided with, again, we see if the colliding pawn has an inventory component. If it does, we add a new inventory item. We then call update from actor to synchronize its state to the inventory item itself. And if we failed to add this item to our inventory for whatever reason, there shouldn't really be a reason for failure in a provided demo. But say if you've overridden your player logic or your inventory logic to say, hey, we can only add one memory target at once or something like that, then this added value would return false. But for the most part, this is going to return true. And if that happens, we'll simply destroy the actor in the world. The reason why we only destroy this if this returns true is that if you fail to pick up this actor, then we should probably just leave it in the world to allow anybody else to come pick it up again. All right. And that's at a very basic fundamental way to store state from an actor in the world and preserve and transfer that state from the actor into the item info. The fundamental thing I'm trying to get across is that you should be overriding update from actor in your custom item info and do everything you need to do here with this actor to preserve its state. Now, if you want to have its state support multiplayer, such as its memory target supports its hits value, generally all you need to do is make sure that the values that you're setting, that you're updating from this actor, are replicated, and everything else should be taken care of. You don't have to worry about any other type of networking. As long as the properties here are replicated in this item info, this item should replicate properly across the network, and your clients should see the same values as the server when they use these items. Now, the weapon system also uses this logic, but it's a little bit more advanced because the weapons have a little bit different form of state and actor representation. But this should be enough for you to spawn an actor in the world and pick it up and retrieve its state if its state has ever changed. Now let's cover how to do the opposite. Instead of having an actor being sent to your inventory, let's cover how to get an inventory to spawn an actor and have its state restored. Now, if we take a look at the invoke of the memory target item info, we see that it's pretty similar to the cube. In fact, it's identical. All we're doing here is we're calling spawn actor. And all this logic is actually identical to how the cube is spawned, except for one very important thing. The slot inventory memory target actor, this one that we're dragging into the world here, its hits value that keeps track of the number of times it's been hit has been exposed on spawn. And what this means is that when this actor is spawned through Blueprint, this property is exposed. So when we select the memory target actor here, we see that this property is exposed. And all we need to do is, because the item info is also storing a copy of the number of hits that it has, we simply wire the item info's hits property to the memory target actor's hits property. And thus, when that memory target is spawned, its hits value is automatically in sync and state is restored from the inventory item. And that's all you really need to do if you know that an item info is spawning a very specific Blueprint class. However, if you have a class variable and wire that into here, this node might not give you the pins that are exposed on spawn. Instead, you might need to restore state a different way. Now, this is more of an advanced use of this, and it's used for the weapon system in both this project and for a generic shooter, but I'm going to cover the basics a little bit anyway. Now, the built-in item info class, again, has two more update functions. It has update from actor if initial spawn, and update from actor if initial spawn using temp actor. Now, these are a little weird, but they are for facilitating state saving and restoration from an actor in the world in different scenarios. For example, for this memory target, when this memory target calls update from actor and when it calls spawn, when it calls update from actor, it simply knows to pull this hits value out of the actor and sets it. But when it spawns this memory target, we simply supply its hits value, but consider the situation where the default value of this item info might be wrong, and we want to defer to the defaults of the actor that we're spawning. Now, what I mean by this is say you know you're spawning a weapon, and your item info doesn't really know how much ammo that weapon should have until the weapon is spawned, because you may have your weapon set up in a way where the default ammo that it has is set up in the weapon itself and not in the inventory items, which means we still need to have a property in the item info in order to store that. But when we spawn an actor, if we don't have that data, we need to pull from the actor itself to update it initially rather than creating the actor with our value, because our value might be wrong. And that's where this node comes in. That's where update from actor if initial spawn using temp actor comes in. It's a long function, but what this function means is that if you are to call it very early on in your spawn actor, before you spawn your actual actor and before you've set initial spawn to false, if you call this, what this does is it sort of pulls from your implementation of spawn actor and update from actor, and it spawns an actor that represents this item info, but it spawns it without an owning actor and without an instigator. It's just a temporary copy of that actor, and it's just to get its defaults. Now, if you know your item info does not need a hard copy of this spawn actor node, and say you can use something like get class defaults, then by all means override this function, rip out spawn actor here, and call get class defaults. But if you know that you need an actual instance of your actor class in order to pull defaults from, then you want to have this logic here. So we simply spawn a temporary copy of this actor, then we immediately call update from actor on it. So what this does is whatever logic you've defined in update from actor for your item info that extracts state information from the actor, we simply extract that from a default actor for your item info. And then as soon as we extract that initial state, we destroy this temp spawn actor. And if we come back to our spawn actor graph in our item info, we'll see that this doesn't output the actor or the new information. Once this is called, it's assumed that all the properties inside this item info are now properly set. For example, if we were to call this, the hits value would be properly set to the default value of that memory target class. And then from here, we can spawn the actor, and our information is going to be valid. So again, if we were spawning a weapon that had a overridden default amount of ammo, then instead of supplying this actor the proper actor that we're going to use and return to the rest of the game system, it's going to supply it a value that came from a temp actor. It's going to supply it its proper default value instead of the default value in the inventory item. Now again, this is completely optional and you don't have to do any of this, and it will be explained further in the weapon system video in order to show you how that works. But it's just a mechanism where if you don't want to keep your actor state synced up with your item infos and you just want your item info objects to pull its state from the actor defaults, then that's one way to do it. That way you don't have to make sure all your item info defaults are always in sync. An alternative way to avoid having to do that completely is to store your default ammo type, your values, your default hit state, your default state in general in the inventory item itself. And because that's always going to be a valid default state, you can simply spawn the actor, supply it this state, and you don't have to worry about that update from actor if initial spawn is in temp actor. Now, on the other hand, this is a use case that I haven't found myself. But if you want to spawn an actor and instead of having it be a temp actor, and if you don't need to supply it default values, say the item info state, its default state is completely irrelevant for spawning the actor, and you want to get the actor's state after you spawn it, but again, it doesn't matter what you sent it to spawn, and you don't want to use a temp actor, then you can call update from actor if initial spawn. And all this does is if the initial spawn flag has been set and the initial spawn flag is true by default, but it's immediately set to false anytime you spawn the actor, update from actor, or call any of the update from actor methods, then we will simply update that actor. This is a good thing to do if, say, you have an actor which the item info state is irrelevant to begin with. You spawn it for the first time. You want the item info to grab that initial state. But say if you pick up that item again and that item is back in your inventory, and when you spawn it a second time, and this time you want the state of the inventory item to drive it, but you don't want to pull from the item's defaults because maybe when that actor was spawned in the world, its state changed for some reason, and then when you picked it back up, you want to preserve that state. When you spawn it again for a second time, because the second spawn is not that item's initial spawn, it should not update from the actor, and you should have your state preserved. So, again, I don't have a use case for this scenario. It's just provided for you to use if you want to use it. Most of the time, you're going to be calling this longer function, update from actor if initial spawn, using temp actor very early in your spawn actor logic, like we have in the provided weapon sample, or not calling it at all. So I know this video is long, and I know I've kind of reiterated some things over and over again, and I've rehashed some things, and it is a little bit more complicated. But if you're able to grasp these concepts and use them, you can easily create very powerful item mechanics with very little work, knowing that you just need to really override spawn actor, update from actor, and invoke if you're using the invoke system. By overriding these, you can have some very powerful multiplayer ready state preserving actors that are transferred to your inventory, and when they're transferred into a lightweight actor that doesn't need to tick, doesn't need to keep calculating things, and when the user selects it, we'll bring it back into the world and really save a lot of performance for everybody. So hopefully this makes sense. If you have ways that you think I might be able to improve this video to improve this explanation, please send those ideas my way, because I know this is one of the tougher concepts of this component. Thank you.